So, for these first impulse problems, we're just going to do a refresher on how to calculate the impulse from a graph. So, in this one, we want to find the impulse, which is J, exerting on a particle with a mass of 0.25 kilograms. So, the force versus time graph is what we need in order to solve the impulse of this. So remember, our equation is J equals F dt, or the area under F versus T. So in this, we're given F in newtons and T in milliseconds. So, this is our 0. For the first 2 seconds, so 2 milliseconds, we have a force that goes like this. And this point here is negative 500. Then we have a big triangle here whose maximum value is 2000. And then we have this point is 8, and then we have another small triangle down here where this point is 10. That also goes to negative 500. So we have 3 regions. We have region 1, region 2, and region 3. Each one of these things is a triangle. So the area of a triangle is 1/2 base times height. So the total impulse equals area of 1 plus area 2 plus area 3. So, area 1. We have 1/2. Our base is 2 milliseconds. Our height is negative 500 newtons. Make sure we keep our negative sign because it's below the x-axis. And then our second area is 1/2. Our base is from 2 to 8, which is 6 milliseconds. Let's make that look a little nicer. 6 milliseconds. And our height is 2000 newtons because it goes up to here. And then our third area is 1/2. From 8 to 10 is 2 milliseconds. And again, negative 500 newtons because our height is here. So, if we take the sum of all these guys, 1/2 times 2 cancels, so that's negative 500 Newton milliseconds, plus 2000 divided by 2 is 1000, times 6 is 6000 newtons milliseconds, minus 500 newtons milliseconds again. So this gives us 5000 newtons times milliseconds for our impulse.